Good afternoon, everyone. My name is Miss Anna May Opod. So now let's discuss about the history of computers. So definition of computer. A computer is an electronic machine that accepts information or data, processes it according to specific instructions, and provides the result as new information. So when we say computer, it is an electronic device which we can access at the same time. We can gain new knowledge which is very important and useful for nowadays. Let's proceed to the earliest computer. Originally, calculations were computed by humans whose job title was computers. These human computers were typically engaged in the calculation of a mathematical expression. The calculations of this period were specialized and expensive, requiring years of training in mathematics. So the first use of the word computer was recorded in 1613, referring to a person who carried out calculations or computations, and the word continued to be used in that sense until the middle of the 20th century. So, in 1613, the word computer was recorded until the middle of 20th century. Our earliest computer is usually engaging in mathematical expression with the use of calculations and computations. So, sa siningang mga time, dapat may aragin kita knowledge about math kay very hands-on sila in terms of computation and calculations. Okay, let's proceed to the different examples of earliest computer. The first one is the tally sticks. A tally stick was an ancient memory aid device to record and document numbers, quantities, or even messages. So, it is used for numerous purposes such as messaging and scheduling, especially in financial and legal transactions. It is made of bones, ivory, wood, or stones. The next one is the abacus. An abacus is a mechanical device used to aid an individual in performing mathematical calculations. The abacus was invented in Babylonia in 2400 BC. The abacus in the form we are most familiar with was first used in China in around 500 BC. It is used to perform basic arithmetic operations. So, it is a Latin word from Greek word which means abax, which represents counting table. So, it serves as mathematical functions such as addition, subtraction, multiplication, and division. So, it is not only a device for helping a human to calculate. At the same time, it helps for the remembering of what is being counted and computed. So what is the difference between the earliest abacus and the modern abacus? So the earliest abacus is made up of stone, wood, or metal with stones and beans to signify numbers, while the modern abacus is made of bamboo or wood frame with wooden beads to represent number. Okay, next let's proceed to the Napier's bone. It is invented by John Napier in 1614, allowed the operator to multiply, divide, and calculate square and cube roots by moving the rods around and placing them in specially constructed boards. So I will present a video in order for you to visualize the use of Napier's bones.
In this quick tutorial, I'll show you how to use Napier's bones to multiply. What you see on your screen is what is referred to as Napier's bones or rods. And what I will do is show you how to multiply 6 times 325 using this ancient method. So here's how it works. The factor 6 gets located on the index rod, and it's found right here. Then we'll focus on the rods for 3, 2, and 5. Now as you go down each of these bones, you'll notice that we have multiples of that number. For example, here we have 3, and the multiples of 3 are 3, 6, 9, 12, 15, and so on. So let me highlight specifically at the index 6 for each of these bones. We have this block, and that block. So we have 3 blocks. I'll create a rectangle and write down their digits. So to represent 3, I have 1, 8. To represent 2, I have 1 and 2. And to represent 5, I have 3 and 0. Now using the Galli method that I showed you in one of our previous videos, we will use these diagonals to help us add the numbers which will end up becoming the product of this question. So you see this diagonal line here? All of these numbers need to be added. We have 0, 0 plus nothing is 0. Moving on to this diagonal, we have 2 and 3. Adding 2 and 3 is 5. Adding 8 and 1 is 9. And 1 on its own is simply 1. So the product or the answer to this is 1950. 1950. Let's do one more for good measure. What if we wanted to multiply the number 9 times 998, for example? Again, we will locate the number 9 in the index rod and then the number 998. So we have this block, again that block, and that block. So let me rewrite that. Okay, starting with 9, we have 8 and 1, again another 9, and finally the last block is 7 and 2. Remember, these are diagonals. So 2, 1 plus 7 is 8, 1 plus 8 is 9, and finally that 8 gets written as it is. The product or the answer to 9 times 998 is 8982. And there you have it. Now you know how to multiply using Napier's bones.
Next, let's proceed to the slide rule. It is invented by William Oughtred in 1622. Based on Napier's idea about logarithms, used primarily for multiplication, division, roots, logarithm, trigonometry, that normally used for addition or subtraction. So, it is used to calculate the length and the total distance of the number. Let's proceed to the Pascaline. It is invented by Blaise Pascal in 1642. It was its limitation to addition and subtraction. It is too expensive. So, it is made of metal, which is also known as arithmetic machine. Like in the Napier's bone, it is used to calculate the basic component of math. Okay, let's proceed to the Sticht reckoner. It is invented by Gottfried Wilhelm Leibniz in 1672. The machine that can add, subtract, multiply, and divide automatically. So, this is the most advanced of earliest computer because you can easily compute or calculate the numbers because it is automatically. So, without using manual or hands-on computation. Okay, next, let's move on to the Jacquard loom. The Jacquard loom is a mechanical loom invented by Joseph Marie Jacquard in 1881. It's an automatic loom controlled by punch cards. So, I will present a video to visualize its uses.
This is a mechanical Jacquard loom. This technology was developed in France in 1803 by a weaver named Joseph Marie Jacquard. The key thing about this loom is that it controls every warp thread, the threads that go from the front to the back of the loom, individually. Because it can do that, the loom can create very complex, fancy patterns in the cloth more quickly and with greater accuracy than the technology available before this loom was developed. These cards are what carry the instructions that are read by the apparatus on the second floor that tells the loom what pattern to create. The holes in the cards are read by a series of pins up in the apparatus, and those holes tell the apparatus which threads down here should be raised for each pass of my shuttle across the warp. Some of you might recognize these cards as looking similar to computer punch cards. Back in the early days of computer technology, punch cards carried instructions that told the early computers what kind of calculations to do. So this loom is the great-great-great-grandfather of the computer technology that we all use today, and that technology started with a machine that produces cloth.
The last one is the arithmometer, a mechanical calculator invented by Thomas D. Colmar in 1820, the first reliable, useful, and commercially successful calculating machine. So the machine could perform the 4 basic mathematics functions, the first mass-produced calculating machine. So it is also perform addition, subtraction, and multiplication, and with some more elaborate uses involvement of divisions, such as integer division and decimal division. So that's all. The next topic will be discussed by Ms. Villorente.
Good day everyone, my name is Alvime Villorente and I'm going to tackle about the difference engine and analytical engine. So first, it's an automatic mechanical calculator designed to tabulate polynomial functions, invented by Charles Babbage, the father of computer, in 1822 and 1834. It is the first mechanical computer. The difference engine and analytical engine both perform for calculations invented by Charles Babbage, known as the father of computer, in 1822 and 1834. So the difference between a difference engine and analytical engine is that analytical engine can perform the 4 operations in mathematics, while the difference engine can only perform addition. Another one is that analytical engine is slower in speed and the difference engine is faster. Analytical engine is much more than a calculator because it can perform and solve any math problem, unlike sa difference engine, which is somewhat like na limited lang iya nga pag-operate. So, analytical engine is programmable using a punch card. So, what is a punch card? Here's the punch card. So, punch cards are the holes that may be punched by a hand or machine to represent computer data and instructions. So, one of the examples of the use of a punch card technology is in the renowned Turing machine invented by Alan Turing. So, next, first computer programmer. In 1840, Auguste Ada Byron suggests to Babbage that he use the binary system. She writes programs for the analytical engine. Auguste Ada Byron was the first to recognize that the machine had applications beyond pure calculations and to have published the first algorithm intended to be carried out by that machine. So by that, she is awarded as the first computer programmer. So naging computer programmer si Ada Byron kay mas na-explain niya maayo ang machine or ang engine na gin-invent ni Babbage compare kay Babbage. Pag mas damo pa siya, may na-discover sa mina ang machine compare kay Babbage. She predicted that machines like analytical engine could be used to compose music, produce graphics, and can be useful to science. Next slide is the Schutzian calculation engine, invented by Per George Schutz in 1843, based on Charles Babbage difference engine, the first printing calculator. So this calculator engine was able to rapidly calculate and print multiplication, division, and exponentiation into a logarithmic table by inputting numbers into the columns and changing setting into either multiplication, division, or exponents. So here is the example of a logarithmic table. So the general purpose of the machine is to produce or to show solution to the same problem by which the English calculating machine constructed by Babbage was designed. So this machine consists of 3 parts: the printing unit, the calculating unit, and the numerator. So next is the tabulating machine. So, tabulating machine invented by Hermann Hollerith in 1890 to assist in summarizing information and accounting. So, this tabulating machine was invented by Hermann Hollerith. This tabulating machine included a punch for entering data about each person onto a blank card, a tabulator for reading the cards and summing up information, and a sorting box for sorting the cards for further analysis. So in short, this tabulating machine summarizes the information being stored on the punch card. So let's move on to Harvard Mark I, also known as IBM Automatic Sequence Control Calculator, or the ASCC, invented by Howard H. Aiken in 1943, the first electromechanical computer. So Harvard Mark I was designed by Howard Aiken. It produces multiplication tables but was once superseded by electronic stored program computers and can also execute long computations. Mark I was an electromechanical calculator that held numbers and mechanical elements which were also electrically controlled. Next is the Z1, the first programmable computer created by Konrad Zuse in Germany from 1936 to 1938. To program the Z1 required that the user insert punch tape into a punch tape reader, and also output was also generated through punch tape. So the Z1 was a mechanical computer designed by Konrad Zuse. It was a binary, electrically driven mechanical calculator with limited programmability, reading instructions from punch tape. The Z1 contained almost all parts of a modern computer: the control unit, the memory, the microsequences, the floating point logic, and the input-output devices. So next is the Atanasoff Berry computer, or the ABC. It was the first electronic digital computing device invented by Professor John Atanasoff and graduate student Clifford Berry at Iowa State University between 1939 and 1942. So the ABC computer is the first electronic digital computing device. So the machine exact operation was to accept two linear equations at a time with up to 29 variables and a constant. So using this data, I could eliminate one of the variables. Next is the ENIAC. ENIAC stands for Electronic Numerical Integrator and Computer. It was the first electronic general purpose computer, completed in 1946, developed by John Presper Eckert and John W. Moseley. So ENIAC was designed and proposed by John Moseley. So ENIAC was designed to be a modular, to be composed by different individual panels that perform separate function, and it was also the first large-scale computer to run solely on electronic components without any mechanical parts slowing it down. So that is for the ENIAC. Next is the UNIVAC 1. The UNIVAC 1, or the Universal Automatic Computer 1, was the first commercial computer designed by G. Presper Eckert and John Moseley. So the UNIVAC 1 was designed as a commercial data processing computer intended to replace the punch card accounting machines of the day. Next is the EDVAC. EDVAC stands for Electronic Discrete Variable Automatic Computer, the first stored program computer designed by von Neumann in 1952. It has a memory to hold both a stored program as well as data. So the EDVAC was the first modern electronic stored program computer to be designed. It was a binary serial computer with automatic addition, subtraction, multiplication, program division, and automatic checking with an electronic or the ultrasonic serial memory capacity of 1044-bit words. This is for EDVAC. So next is the Osborne 1, the first portable computer released in 1981 by the Osborne Computer Corporation. So Osborne 1 is widely considered the first portable personal computer ever, which includes monitor, disk drives, and all components. The computer shipped with a large bundle of software that was almost equivalent in value to the machine itself, a practice adopted by other CP or M computer vendors. Lastly, the first computer company. The first computer company was the Electronic Controls Company. So, mani siya ang first computer company. So, founded in 1949 by J. Presper Eckert and John Mashley. So, Electronic Controls Company designs, manufactures, and markets emergency lighting and valuable warning equipment. This is also a company which designed and built UNIVAC computers. So that's all for my report. So the next slide will be tackled by Miss Taiko. Thank you for listening.
So, I am Abigail Taiko. I'm going to discuss computer generation. So, there are 5 generations of computer. So, the first generation. So, the first computer used vacuum tube for circuit and magnetic drums for memory, and were open enormous taking up entire rooms. They were very expensive to operate in addition to using a great deal of electricity. Generated a lot of heat, which was often the cause of malfunction. First generation computer relied on machine language, the lowest level programming language understood by the computers. To perform operations, and they could only solve one problem at a time. Input was based on punch card and paper tape, and output was displayed on printout. So, in 1946 to 1958, first generation was developed. So, first generation computer used a lot of vacuum tube. It consists of a glass bulb and wire. Kag ang size niya is daw kaangay sa isa ka balay, kag required gid ang huge amount of electricity. Kaysa ang una, wala pa nakadiscover ang mga scientists nga mangin efficient ang computer. So, next, the second generation. So, transistor replaced vacuum tube and ushered in the second generations of computers. One transistor replaced the equivalent of 40 vacuum tube, allowing computers to become smaller, faster, cheaper, more energy efficient, and more reliable. Still generated a great deal of heat that can damage the computer. Second generation computers moved from the cryptic binary machine language to symbolic or assembly language, which allowed programmers to specify instructions in a word. Second generation computers still relied on punch card for input and printout for outputs. These were also the first computer that stored their instructions in their memory, which moved from magnetic drum to magnetic core technology. So, the second generation computer were developed between 1959 to 1964. So, second generation computer used transistor instead of vacuum tube, kay mas naging efficient kag effective ang transistor kisa sa vacuum tube. So, next, the third generation. So, the development of the integrated circuit was the hallmark of the third generations of computer. Transistors were miniaturized and placed on silicon chip called semiconductor, which drastically increased the speed and efficiency of computer, much smaller and cheaper compared to the second generation computer. It could carry out instructions of billions of a second. User interacted with third generation computers through keyboard and monitors and interface with an operating system, which allowed the device to run many different applications at one time with central program that monitored the memory. Computer for the first time became accessible to a mass audience because they were smaller and cheaper than their predecessors. So, in 1965 to 1970 was the period of the third generation's computer. So, an integrated circuit is as small as a transistor, but it works as fast as thousands of them. So, may ara na nga na-create ang industry sang software and hardware, kag may ara na nga programmers, kag mas naging magamay na siya kaysa sa mga nauna nga generation. So, the fourth generation, the microprocessor brought the fourth generations of computer as the thousands of integrated circuits were built onto a single silicon chip. As this small computer became more powerful, they could be linked together to form network which eventually led to the development of internet. Fourth generation computer also saw the development of GUIs, the mouse and handheld device. So the computers developed since 1971 up to the present are called the fourth generation computer. So the fourth generation computer used microprocessor. It consists of a small silicon chip on which thousands of circuits are placed. Ang iya size is magamay na kag ang iya speed is madasig na kaysa sa mga nauna nga generation kag ang iya size bala makaigo na sa isa ka table. Kag diri man na conceptualize ang personal computers. So last, the fifth generation. Based on artificial intelligence, still in development, the use of parallel processing and superconductor is helping to make artificial intelligence a reality. The goal is to develop devices that respond to a natural language input and are capable of learning and self-organization. So there are some applications such as voice recognition that are being used today. So the fifth generation's computer are the most advanced computer. Scientists are now developing fifth generation computers in a way that they can think on their own. This is called artificial intelligence. So today, computer are made in different sizes so that magamit siya in mga tao in different purposes. So, just like for example, so for computers and mainframes, muni nagamit sang mga scientists kag mga engineer kayang iya nga amount of data is dako. So, mini computer muni naman nagamit nato ng mga estudyante, ang mga teachers kag ang mga gobra sa opisina. So, mobile computers naman muni or tablet muni naman nagamit nato ng cellphone or tablet. So, that's all. Thank you.